now move on to the kinetic energy. So we have our terms here. Energy. Energy is defined as the ability to do work, or is anything that can be converted into work. There are two types of energy. First, the kinetic energy, where it is the energy in motion. The second one is potential energy. It is the energy at rest. So for kinetic energy, we have our formula here, 1/2 mv squared, where K is equal to kinetic energy, which also has a unit of joules, V for velocity, and the unit for velocity would be meter per second. I'm sorry for this. And our mass would be kilogram. Okay, next we have work energy theorem here, where work is equal to the change in kinetic energy. Isn't it work is equal to force times displacement? And the formula to the change of kinetic energy is 1/2 mv squared, mv sub 2 squared minus 1/2 mv sub 1 squared. So work is equal to the change in kinetic energy. Next, on problem number 4, what average force is necessary to stop a 16-gram bullet traveling at 260 meters per second as it penetrates into the block of wood for a distance of 12 centimeters? Let us now solve for problem number 4. By listing first our given mass is equal to 16 grams, when converted into kilogram, that will be 0.016. Our V sub 1 is equal to 260 meters per second. Our V sub 2 would be 0 meter per second. Our displacement will be 12 centimeter. When converted into meter, that will be 0.12 meter. So for the solution, we are looking for the force. So we're gonna solve for force with the formula W is equal to 1/2 mv sub 2 squared minus 1/2 mv sub 1 squared. We know that work is equal to force multiplied by displacement multiplied by cos theta. That's work energy theorem. So conversion, force, of course, unknown. Our displacement is 0.12 meter. Our cos is cos 0 degrees. 1/2. Our mass will be 0.016 kilogram. V sub 2 is 0 meter per second squared. Minus 1/2. Our mass is 0.016 kilogram. Multiplied by V sub 1, which is 260 meter per second squared. So we divide both sides by 0.12 meter and cos 0 degrees. Both sides. Later on, I will write the other one on the right side. So force is equal to negative 0.016 kilogram multiplied by 260 meter per second squared over 0.12 meter multiplied by cos 0 degrees. So our force is equal to negative 4,510 Newton. That will be our average force. Next, and problem number 5, a 12.0 Newton force with a fixed orientation does work on a particle as the particle moves to the three-dimensional displacement, such as a displacement of 2.00 I minus 4.00 J plus 3.00 K meter. So what's the angle between the force and the displacement if the change in particle's kinetic energy is at A, positive 30 joules, and B is negative 30 joules? To be able to solve it. So for problem number 5, we will still write our given. Our force is 12 Newton. Our displacement, we could solve it by square root of 2.00 meter squared plus negative 4.00 meter squared plus 3.00 meter squared. Our displacement would be 5.39 meters. So we are looking for the angle between the force and the displacement. So if our kinetic energy is 30 joules, we know that kinetic energy is equal to work, and work is equal to force multiplied by displacement, and is equal to force multiplied by displacement multiplied by cos theta. So in order to solve for theta, we have our cos multiplied by the kinetic energy over force multiplied by displacement. Substituting our givens, that would be r cos multiplied by 30.0 joules divided by 12 Newton multiplied by 5.39 meter. Entering that on our scientific calculator, that will be 62.3 degrees. That will be our angle if our kinetic energy is 30 joules. So if our kinetic energy is negative 30 joules, we will repeat the same process. It will be cos negative 1. Our kinetic energy there will be equal to negative 30 joules. So cos negative 1, negative 30 joules over 12 Newton multiplied by 5.39 meter. Our theta is equal to 118 degrees. So that is the angle between the force and the displacement. Next, problem number 6. The only force acting on a 2.0 kilogram body as it moves along a positive x-axis has an x component of Fx is equal to negative 6x Newton with x in meters. The velocity at x is equal to 3.0 meter is 8.0 meter per second. For letter A, they are asking for the velocity of the body if x is equal to 40 meter. And at letter B, they are asking for what positive value of x will the body has a velocity of 5.0 meter per second. Let us now solve for problem number 6. Our given mass is 2.0 kilogram. Our F sub x is negative 6x Newton. Our x sub 0 is 3.0 meter. Our v sub 0 is 8.0 meter per second. So our solution at letter A, we have our x there, which is equal to 40 meters. 4.0 meters. So work is equal to the integral with limit. So we will use that formula. We'll do substitution now. Our x is 4. Our x sub 0 is 3. Our f sub x negative 6x dx. So integration, basic integration, guys. So how would we integrate negative 6x? That would be negative 6x. Integral of negative 6x is negative 6x over 1 plus 1. And the exponent will also be 1 plus 1. So, negative 6x squared over 2. Our answer there will be negative 3x squared. So, negative 3x squared, which has a limit of 4 and 3. Substitution, negative 3. Let's start with 4. 4 squared minus negative 3 multiplied by 3 squared. Solving, that would be negative 21 joules. So we already have our work there. We're looking for the velocity. We will use formulas. Work is equal to kinetic energy is equal to 1/2 m multiplied by v squared minus v sub 0 squared. So our work would be negative 21 joules equals 1/2 m would be 2.0 kilogram over v squared is unknown because we're looking for the velocity, multiplied by v sub 0. I'm sorry for the zero there, but imagine that it's not there. Multiplied by 8.0 meter per second squared. So v squared is our unknown. So in order to solve for the v, we will have v is equal to the square root. We will do cross multiplication there. That will be 2 multiplied by negative 21 joules over 2.0 kilogram plus 8.0 meter per second squared. Putting that on our calculator, that would be 6.56 meter per second. That would be our velocity of the body if x is equal to 4.0 meter. At letter B, at what positive of x? So we're looking for the x. Again, we'll do the solution like on letter A. But here we don't have our limits. So that will be limits of x and x sub 0. Our f sub x is negative 6x dx. Again, integration, it will be negative 3x squared, which has a limit of x and x sub 0. Substitution, that would be negative 3x squared minus x sub 0 squared. Next, we already have our work there. Formula again, which is work is equal to kinetic energy, which is equal to 1/2 mv squared minus v sub 0 squared. Our work will be negative 3 multiplied by x squared minus x sub 0 squared is equal to 1/2 mv squared minus v sub 0 squared. Substitute our given, that would be x sub 0 is equal to 3.0 meter per second. Meter second. And our mass is 2.0 kilogram. Our velocity as given is 5 meter per second minus 8.0 second squared. We are looking here for the x. So we do cross multiplication and transpose. That will be x is equal to square root of negative 1/6 multiplied by 2.0, that's 2.0 kilogram, multiplied by 50 meter per second squared. 5.0, that's 5.0, I'm sorry. That's 5.0 squared minus 8.0 meter per second squared plus 3 meter squared. So our x would be 4.69 meter. That would be our positive value of x, whereas its velocity will be 5.0 meter per second. This is our references. Thank you for listening. See you in the next lesson.